Okay, so let's continue. Once you come to this side, when it comes to binning, we can do the option, we try to bin those X values, which means we want to put the X value into the groups. So let's do custom. And we understand the interval width, which is the width of each class, is going to be 5. So put 5 there. And the custom value for anchor, this is where the first value would begin with. So we understand we should begin with 35. So the 6 categories should start with 35, which and with a width of 5. Hit apply. And this time you would see it has been grouped into 6 categories as what we want to have. Okay, so that is how you try to get a histogram for a grouped frequency distribution. Okay, over next we want to talk about how to use SPSS to take care of the quantitative variables, which is for categorical variables. Example we're going to do is this variable, which is the gender, okay, female, male, and female. We want to construct a bar chart for the variable gender. Okay, so I'm going to tell you how to input the gender as a qualitative variable into SPSS. First of all, let's go to variable view and create this new variable called gender. And type, we're going to use number to represent a gender. And numbers are going to be whole numbers, so decimal is going to be 0. The label is going to be gender of the respondent. And let us try to define the values. Suppose 1 is female, 2 is male, or 1 is male, 2 is female. Okay, so let us try to say 1 is female, value 1 represents female, and value 2 represents male. So what you do here is, let's put over here the values. And 1 is female, add. 2 is male, add. Hit OK. Okay. And then because gender is categorical data, we go nominal for measure. We're not going to order them, so nominal. So going back to data view, you're going to have this new variable gender being created. And so you can type, say, 1, 1. Okay, so like our raw data is female, female, male, male. So female is going to be 1, female, female, male, male. Just enter the numbers for the label, the values. If you want to check to see if these numbers are correct, you can go View, Variable Label, check Variable Labels. It should show you female, female, male, male, which is in the right order. Okay. So typically, you can just see 1 or 2, and by reading the values, you should be understanding 1 represents female and 2 represents male. Okay, so in my SPSS sheet, I have gender inputted as 1s and 2s. Let me change the decimal to 0. So gender, I want to have 0 decimal places. And let me check if the data are consistent with what the original data set gives us. So again, view and check value labels. So that should give us female, female, and male, males. Okay, I want to know what's the frequency distribution for gender. So same thing. Let's go analyze and descriptive statistics and frequency. And let's pull the gender of the respondent to the right for variables. Display frequency tables, frequency distribution. For the charts, we've got to be careful for categorical data. For categorical data, which is gender, we no longer use histogram. Instead, as we have said in our lecture, we use bar charts. So bar charts for categorical data. Hit continue. Over here you have two options. You can do chart values as frequencies or percentage. We can try both. Okay, they should look very similar in the end. Continue. hit OK. So this is the first graph that we see. Here is frequency distribution. It tells us 13 female and 12 male, 52% of female and 48% of the male. And on the vertical line here, we have frequency. Okay, 13 for female and positive 12 for male. That's what we have if we hit the frequency for the values. Now, let's go back here and do analyze, descriptive statistics, frequencies, uncheck display frequency tables, still work on gender of the respondent, let's do charts, still going to be bar charts, but this time let's call percentage, continue, hit OK. Alright, so this time you see the graph looks very similar. Okay, this graph and this graph. Only difference is on the vertical axis this time talks about what's the percentage of female, what's the percentage of male. Okay, so the percentage is going to be 52 versus 48, so 52, 48, which is consistent to what we have for the frequency distribution. Okay, so that's what we can do by using SPSS for a distribution of one variable. Next, let's see what we can do for SPSS for distribution of two variables, which means we're exploring what's the relationship between two variables. Okay. So let's do first example as we have seen in the lecture. This is talking about two quantitative variables. We have variable beers, which means the number of beers that a person has consumed, and the variable of reaction time, the reaction time. So the beers are listed as 0 beer, 1 beer, and 2 bottles of beers, and the reaction time has been listed. We want to test if there is a relationship between more beers a person has and he or she may need more reaction time. So we will be constructing a scatter plot for those two variables. And again, you'll be entering these two into the SPSS in the same way. Here's the beer, here's the reaction time. Okay, so here in SPSS, I have entered those two variables into the columns of beers and reaction time. Okay, well, I'm calling it as reaction underscore time. So it's the same thing as we see in the slides, PowerPoint slides. So what we need to do is we're going to construct a scatter plot between these two variables. So what we need to do is sketch a graph. So go to the graphs, legacy dialogs, and hit scatter/dot. So we can just pick simple scatter, hit define. So you should not have anything there. So we want to see if alcohol consumption increases, the reaction time increases as well. So x-axis would be your independent variable, which is alcohol consumption. And y-axis is going to be the reaction time as a result due to these two. Okay. And you can also edit the titles. Okay, you say the title is reaction time versus alcohol consumption. Those are something you can do. Okay, hit OK. So we would come up with this graph, which is the scatter plot. On the horizontal axis, we have alcohol consumption. On the vertical axis, we have reaction time. And based on this graph, looks like if alcohol consumption increases, the reaction time increases as well. Because basically you can draw a line going up, right? So the trend is increasing. Alcohol increases, reaction time increases. That makes sense to us by using common sense. The next example we want to do is about two qualitative variables. Okay, suppose gender and a candidate. This problem, suppose we want to know if there is a relationship between a person's gender and his specific preference to male candidates, A or B. So we want to know if female may like A or B better, male may like A or B candidate better. Okay. So in this case, we're going to construct a crosstab, which is called contingency table in the SPSS. We can also get a graph, which is called the clustered bar graph for the data set. So in the SPSS, you'll be entering gender, which I assume you would already have it, and a candidate. Same thing as we did before for gender. For the candidate, okay, you can have two values. You can simply say 1 represents candidate A and 2 represents candidate B. So we want to use these two columns to generate a simple crosstab to examine the relationship between gender and candidate. So let's go Analyze, Descriptive Statistics, and we're going to choose the option of the crosstabs. See, I have stuff there already, so I'm going to move on. Alright, so for the rows, I can put the gender of the respondent to the rows, and columns can be the candidate they would prefer. The gender of the respondent and the preferred candidates. For the cells, that is what we want to have for our table. So first of all, we can get the counts as observed, which means what you get from the original raw data. Okay. We don't have to do any percentage as of now, but if you want to, we can check on the total percentage and then continue. Hit OK, and you will have two outputs, okay, coming up again. So this output, first of all, the first output tells us we have 25 gender, 25 people has been responded as the total total number of data values. And this is the corresponding cross tabulation which examines the results relationship between the candidates and female and male. So if you read this table, it tells us 6 people are female and also prefer A. 7 people are female and also prefer B. 8 people are male and also prefer A, and 4 people are male and also prefer B. In total, we have 13 people that's female and possibly 12 as male. And we had 14 people who would prefer candidate A, while there are 11 people who would prefer candidate B. So that's if you look at those whole numbers. Next, let's look at the percentage. Okay. And we have done a total percentage. So basically it means like out of these 25 people, we have 24% of the people that is female and also prefer A, 28% of people that is female and also prefer B. 32% of people are male and prefer A, 16% of people are male and also prefer B. 56% of people would prefer A, 44% of people would prefer B. It also tells us 50% of the respondents are actually female, and 48% of people are male. Okay. These, in total, we add up to have 100%, which includes everything. Okay, we can look at more about the percentages. So if we go Analyze and Descriptive Statistics, go the crosstabs, keep these two in the rows and columns, and change the cells to the percentage to row percentage. That's going to give us something else that we can examine. So continue, hit OK. Alright, this time you notice that each percentage, okay, for the rows are 100%, 100%. So that tells us something new about female and male. Let's continue this in the next video.